Namaskar friends, welcome back to Mohanjanix. I hope all of you are safe and healthy and your studies also going well. So without any delay, पढ़ाई शुरू करते हैं. In our previous lectures, we have already discussed about concept of orthogonality and it's used to calculate power of different kinds of trigonometric functions using some trigonometric formulas. Concept of orthogonality can also be used to calculate RMS or power of some waveforms like this. This waveform we have to calculate RMS value. So we will use here concept of orthogonality to calculate RMS value and we will see that how it will be useful and it will be less time consuming. So let's start. As we can see that this is the waveform where some square kind of form is in the positive side and triangular waveform in the negative side. To use concept of orthogonality, we will split this xt into two parts such that both the signal will be orthogonal to each other. So what we will do, we will first draw x1t which includes only positive side such that this will be our waveform, this negative, and from this point it is again square wave, and from this point it is again square wave, and it is continuing up to infinity. In the negative side it is similar to the positive x-axis. Okay, so it is become like this. So this will be our x1t, which is a square waveform where whose signal is a naught in the half of the time and 0 for the rest of the time. So this will be our first signal, and what will be our second signal? We have to make these two signals such that by adding these two signals we will get xt. So x2t will be, this will be x2t and this is x1t. X2t will be the rest of the signal. Rest of the signal is triangular waveform in the negative side. You can see I have left this part and then again it will become like this. So it will continue up to infinity. And negative side will be also like this only, like this. Okay, this is negative t-axis, this is positive t-axis, and this is positive t-axis. Okay, so we can say that xt xt is equal to x1t plus x2t, and also we can say that if we multiply these two signal x1t and x2t, what we will get? You can see that in this period of time, that is t naught by 2, this is 0, and 0 into anything means if we multiply x1t into x2t in this period of time we will get 0, and for this period of time, that is from t naught by 2 to t naught, this is some value, there is some value in this x2t, and but x1t is 0, so it will ultimately becomes 0. So also if we integrate these like this, what we will get? 0. So as we know from the concept of orthogonality, if any two signal is such that integration of x1t into x2t within that time period is equal to 0, then x1t and x2t are called as orthogonal signal. These two will be orthogonal. And for orthogonal signal, if xt is such that x1t plus x2t, then power of xt will be power of x1t plus power of x2t. This is using concept of orthogonality. And we already know from our previous lectures, for square wave which is like this, what is our power? This value is as a naught, so peak amplitude square by 2. And what is the triangular waveform which is like this? Power of this triangular waveform we have already studied in our quickest method to calculate power of triangular and square waves. If you don't know about that quickest method, you can watch that lecture and understand it clearly. As of now, I am directly writing power of this triangular waveform is a naught square by 6. So power of xt will become 6 here, 3 plus 1 a naught square, and this 4 is equal to 2 and 3, that is 2 a naught square by 3. But what we have to calculate? We have to calculate RMS value of this xt, and RMS value we already know RMS value is root over power, so it will become root 2 by 3 a naught. And what is a value of a naught? Value of a naught is given in the question, that is 6, so it will be root 2 by 3 into 6. This will be our answer. So easily we have got RMS value of this signal. If you know all this concept, it will take less than 1 minute. So using concept of orthogonality, we can easily find RMS and power of any waveform which can be splitted into orthogonal signals. दिस इज एंड ऑफ दिस लेक्चर। उम्मीद करता हूं आप लोगों को ये वीडियो पसंद आया, ये लेक्चर समझ में आया। अगर हाँ तो इस वीडियो को लाइक करना ना भूलें, अपने दोस्तों में ज्यादा से ज्यादा शेयर करें, और कोई भी डाउट हो या कोई सजेशंस या फीडबैक हो तो उसे कमेंट सेक्शन में लिखना ना भूलें। मेरे साथ इसी तरह जुड़े रहने के लिए चैनल को सब्सक्राइब करें और बेल आइकन को भी प्रेस कर दें ताकि आपको सारे वीडियो की नोटिफिकेशन सबसे पहले मिल सके। धन्यवाद दोस्तों, जय हिंद।